we are going to use a burette to do a strong acid, strong base titration. So we need to go over how to properly prepare a burette for a titration. To do that, you want to rinse the burette out with tap water a couple of times, distilled water a couple of times, and then you also want to rinse it out with about 5 or 10 milliliters of the solution you're going to titrate with before filling it completely. This will ensure that your burette is not contaminated. The other thing we need to make sure to do is to get rid of the air in the tip of the burette. So you have to run some solution through the burette to get rid of the air in the tip of the burette, otherwise your calculations are going to be off. So make sure you prepare your burette correctly before beginning the titration. So what we have here is a 0.1 molar solution of HCl in the beaker, and in the burette there is an unknown concentration of sodium hydroxide. So we have a strong acid, strong base titration, and you can see the pH up there at the top of the screen. Right now it's at 1.38, and what I'm going to do here is go through a series of additions of this NaOH. I'm going to add 2 milliliters at a time for a while, until I start getting close to the end point of the titration, and then I start adding less and less milliliters at a time, and you can start seeing the pH change more drastically as we get towards the end point of the titration. So you're going to see a nice level curve to start with, not a significant change in pH, and then there's going to be a real steep curve within a few milliliters, and then it's going to level back off again. Just watch the titration as I go and notice what happens to the pH after each addition, and that should help you make your sketch. The graph you made should look very similar to this one. Any strong acid titrated with a strong base will have the same shaped curve as you see here. There are some important features we need to discuss about this titration curve. The first one being the equivalence point. For a strong acid titrated with a strong base, the equivalence point is at a pH of 7. The equivalence point is when the moles of acid equal the moles of base. And in the case of the strong acid, strong base titration, when the moles of acid equal the moles of base, you have complete neutralization of the acid, and the pH is 7. Once again, this is called the equivalence point. You'll notice that very near the equivalence point, we get a drastic change in pH within a very small amount of base being added. So the pH
rises steadily, not very much, and then all of a sudden, right around that equivalence point of 7, with just a drop or two of base added, you get this huge change in pH that could change up to 6 pH units. That is also a common feature of a strong acid, strong base titration curve. Typically, when we do a titration, we do not have a pH meter in the chemistry classroom. We use an indicator. So there are a variety of different indicators you can use, as you've learned. Some good choices for this titration may be methyl red, bromethymol blue, or phenolphthalein. Well, methyl red will change color from red to yellow as the pH goes from 4 to 6. Phenolphthalein will turn from colorless to pink as the pH turns to about 8 to 10. We are going to use phenolphthalein simply because it's easier to see a colorless to pink color change at the end point. Well, you may think that the pH when the color change occurs is higher than 7. Won't that cause a problem? Well, let's look at that in our graph. So the phenolphthalein will change pink at about a pH of 9. And you can see on our diagram here that we are talking about drops of base being added in a difference of pH 7 to pH 9. So the fact that the pH at the end point of the titration, where the color change occurs, is not the same as the pH at the equivalence point is not too big of a deal, because we're talking about a very small difference in the amount of base that has to be added to reach those two pH values. In the video, you did not see the color change as I was titrating. So I want to show you the desired pink endpoint that we want when using phenolphthalein. The picture here in the lower left is what we call a kiss of pink. This is the endpoint color that we are going for. A very light pink, barely noticeable. This is what it looks like in a beaker. You guys are going to titrate in a styrofoam cup, so you can also see what that same solution looks like in a styrofoam cup. It's going to look a little darker against that white background. The picture in the upper right is what we call make-out magenta. This is way too pink. There's too much base in this solution. If you tried to do your titration calculations using the values that you have in this titration, they are going to be wrong. So you need to go for the light pink, kiss of pink, not the make-out magenta, when you do your strong acid, strong base titration.